Alright, so let me show you the steps as to how to be able to do sequence alignment on a remote server or on a remote computer, which we can also call it a server. So I'm going to pull up some slides, but in that case I'm going to share my screen, and then we can do it step by step. Watch the video to the end, and then I'm very sure that you're going to understand every bit about it. So that when you are going to do it the next time, so let's assume that this is one of my terminal. I could just close all the terminals, and then I'm going to close this. If you are using your MacBook, you should have some terminals in which you are able to write your Unix commands and whatsoever. If you are also using Ubuntu, you should have the terminal. If you are using Windows, you should have the Windows terminal. And then of course you can also use a Git bash, and then you are able to connect, or you are able to get a terminal. But whichever way you have, I am using Ubuntu terminal on Windows, so you can see it is here. I'm going to open it. So that opens, yeah, and you can see the terminal here. Right click on that, and then you will see the Ubuntu terminal again. When you do that, two terminals are opened. Now I have one terminal seated, another terminal is also here. I could just minimize it and have the two of them. I could just push this down this way. Then I can also push this one maybe up to this point. I just want to work concurrently for us to see how this works. It's not really that difficult. So okay. So now I want to do multiple sequence alignment, but I want to do it on a remote server. After that, I will show us how to be able to do other forms of alignment. So I have this, so let me connect one of these terminals here. Let me connect one of them to a remote server which is seated somewhere. And then, so what I'm going to do is just give the address. This is the address of the server. And then I'll just put my password, then I get to the server. So I'm connected to the server right now. So Control L, that is, you can see that at the back here, I have, this is the name of the server, and then I am there. So this is my local terminal. Now, this particular terminal on my right hand side, that one works with my local computer. That's what I'm going to use this particular terminal to be able to navigate around my computer. This particular laptop I am using right now. This one is going to help, is already connected to a remote server. That's another computer seated far away from here. I should be able to copy files from my computer here to the server, and then allow the server to work with it. Then I bring the files back here. Those are the processes. So for us to be able to do a multiple sequence alignment, let's look for the files that we are going to use. So I'm coming to my browser. I'm just going to open here and then do this. You have your Uniprot, uniprot.org, then that is going to open. Then maybe you have these proteins which are sitting there. Whether it is proteins you want to do, it is DNA. As you can see, there are quite a number of them. Now let's search for a particular protein. Let's search for like SARS-CoV-2. Let me see. SARS, what is it, CoV-2? I don't know if there are some deposits proteins of SARS-CoV-2. Sorry, there is none like that. And then let me search for coronavirus. I don't know if there are some like that. coronavirus, maybe coronavirus. It appears there are after, so it's searching for right now. So we can see that, yeah, we have quite a number of the coronavirus which are here. So these are the proteins. So I want to tick. I'm going to tick here. Tick. Just tick these ones. Tick this. Tick these ones. I don't know how many I have ticked, but it's okay. Whichever ones that, irrespective of how I have ticked it. So I need to download this. I don't want it to come in a zip file. So around here, I'm going to uncheck yes. If you click yes, it will be compressed. Compressed means a zip file. There are not too many. I just ticked only 17 of them. So I said no. Then I come and click download. So it's going to link, and then it has been downloaded, which is here. So you can see that the file has been downloaded. Now, if I can go to my downloads and then go and look for where the file has been downloaded. So my downloads is already here. Let me look for it will obviously be under Uniprot. So go down and look for where we have a Uniprot. I'm quickly going to look for where. So I'm looking for where the file is, the download file, so that I can do some few things. Okay, yeah, it is here. Yeah, I hope it's one of these. Maybe let me open this one and see. Yeah, I think it's this one.
These are some of the
yeah, that's coronavirus. So it's that particular file. So what I want to do is I want to rename it into a name that is very unique. So I'm going to call that corona.faster. When I do that, that file is not there. So we want to work with this particular file. But one of the things I always advise is, you see that the names that are here, you edit them. So I'm going to come here. I'm going to delete this part. Never delete the prompt. The prompt is what allows the system to be able to read it. Here, another spike protein is here. This is coronavirus, the one that we are all familiar with. So let's try and do some analysis of this virus and see whether we can make sense from it. So I'm just editing it. I'm doing all these things because sometimes when we see data and it is clean, somebody has actually cleaned it. But trust me, in its raw form, it has all these impurities. Besides, when you do the clustering, it becomes very tough for you to be able to make sense from it with all these long names. But when you clean it like this, it makes sense. You are able to do, yeah. And so I'm going to do all the cleaning, and I want you to follow all the processes. Don't leave any of them out. Yeah, so just come in here. And then we are almost done. Okay. Remember, you can never clean your data with the prompt. Yeah, but there's a very unique one here. I don't think this one is from coronavirus. So let's see how the analysis is going to look like. This is spike. Once you see spike, obviously, another spike glycoproteins are also here. So all these are part of the processes for you to be able to make good analysis. And then when we are done with this, yep, we are finished. So now we have finished editing the file. So we do Control S, then it is saved. Then we come and close it. Now we are done. So let's get back to our terminals. And then our two terminals are here. Now this is my local computer. So this particular terminal on the right hand side allows me to be able to go through my local computer. That's what I call the local terminal. This one allows me to have access to whatever that is found on my server. So now let's come here to my local computer. That's where I'm going to be doing the work for now. So we come here and say ls. So you see I have a lot of things there. So I'm just going to clean that and say pwd. So that's my current working directory. But I want to go to my downloads. Now if I say, if I do ls now, you won't find downloads here. Because I'm using the Windows terminal, this is how we follow it. So I'm going to cd mnt and then c/user and then / okay, and then this, and then I am going to go into downloads. Now under the downloads, I've already downloaded it. There's a file there called corona.faster. So I want to have a view of that particular file. So I'm going to say that if not, I could have list. If you do list, it would have listed the file for me to see, but I have too many things on my download. So if I list, you're going to have too many things. You even know where it is hiding. You can see how it is. But if you don't mind, we can go to the C column, and then you are going to find. If you go to the C column, you are going to find coronavirus somewhere. .faster. So that's why it's always, I always prefer that. I guess, yeah, you can see it is here where I've highlighted corona.faster. So that is why. So I'm just coming to clean this up, and then we want to have a little view of it. So I'm just going to say head, and I want to see the first 10 lines of that file, and then I'm just going to say corona.faster. Faster. So that comes there. So it gives me the first 10 lines of that particular file. So now I need to make sure that I copy that file onto my server. Now I have to go to the server and then go and create a file there, or create a folder there. So I'm coming to my server right now, and so I'm simply going to list what is found on my server. See that on my server I don't have too many things, but I want to create a file there called SARS-CoV-2 or a folder. So I'll just say make directory ma make there and give it a name. The name I want to call it is SARS. I want to call it, or let me put everything in SARS. What is this? So let me just put it. Oh no, Corona. I think I want a name that can resonate. Coronavirus. Let me just put it that way. So now I can CD to that Corona, and then that comes, and then it is over there. Now, it means that the file I have on my local computer which I downloaded, coronavirus, I want to copy that file to my local computer, to my server. But when I copy it to my server, I want it to be in this directory called coronavirus. So I already have the coronavirus here. So what do? You do pwd here. It tells you that this is the root, the absolute path to where the folder is seated. So leave it that way. Now when you come to this place, if you come to your local computer, this is where we do copying. You don't copy from your server, you copy from your local computer. And now on my local computer, I am going to copy from, I'm copying to a server, so you use SCP. We are copying a file, okay? But before that, this is the simplest way I always do pwd, and then you see this, copy this one here, that's on your local terminal. Then Control C, Control Shift and C, it copies it. Now when you come to the SCP first, because you are copying a file, you don't have to put -r, so you just put whatever that you are. So I'm copying from this, I'm copying that file from my local computer, and this is the absolute path to my local computer, but I'll put / here and put the name of the file there. So I have corona dot, no, I think it's corona dot f faster. So I am copying this file onto my server. So now I have finished all the path, the absolute path to where the file is seated, this corona file that I'm taking to my server here. Now I need to put the address of the server, where the file is going to. The address of the server is I've already, that's the address of my server, the server I'm connected to at 192.168.0.151. Oh, sorry, I haven't finished. So when you finish like this, or when you are here, we are copying all the way this particular file here, which I have highlighted here. We are copying it all the way to this particular server, but we have indicated the address of the server. The next thing is to make sure that we put column and say that when we get to the server, we want to put, the server is not for one person. That's one thing I want us to remember. Server is meant for too many people, but when you go to the server, the address I've put here is for the server. But when you go to the server, too many people are having folders and files and whatsoever seated there. So why do you want to put it? So you now come to this side, copy. This is where I want it to be. I want the file to be, when it go to the server, it should look for the cluster where BigBar is, and then it should look for the folder called coronavirus and put it there. So you copy that particular path and come and join it here. And you see that, so now this is the full path. So I am copying this called coronavirus, which is found in my downloads, under BigBar, and then under user whatsoever. And I'm copying it all the way to this server address from here up to this place. When you get to the server, look for home, look for BigBar, and look for coronavirus and put the file there. So the file will go and be sitting in coronavirus. But before I run it, if I had come here to the server, you see that this folder that I created, coronavirus, there's nothing in it. If I say ls, you find nothing. But when I copy, you will find that the coronavirus.faster will not be seated there. So now when I come here, I am done like that. I can just run that file. It will ask me for password, and then when I do that, so it has finished copying. So now if I come to my server right now and I do ls, you see that the coronavirus is not seated on my server, far away from here. And now I can now begin to work with my server. What is the next thing to do is to now do my alignment. To do my alignment on the server, it means that I have a tool already installed, which I call it. So now let me slide this a little bit so that there will be more space for you to see clearly. Now that I am on the server and then I am also on the coronavirus side, I'm now going to do my sequence alignment. So to do sequence alignment, you need this called cluster low. So I have my cluster low here. If first of all you need to know how the cluster low, some of the flags and whatsoever. So you just do cluster low -- and then you can come. This is going to give you how you are able to use all these flags which are there. You see that it can be done for clustering, which is here. Look, this is how the input is going to look like, and then you can have your everything, alignment, output, how it's going to, the iterations whatsoever, then miscellaneous. All these things allows you to be able to know how to use like the the cluster low. So this how. So let me clear the screen, make it clear. So I'm going to do my, so I have my cluster low, then I have this, -I, which means my input. So where is my input file? My input file is found here in coronavirus. It's called corona.faster, so it completes it for me. And then my output file will be -O, which means output. The output, what do I want it to be? I want it to be corona underscore alignment, because what I'm going to do is call an alignment. And so alignment, how do I want the alignment to be? I want it to be in a faster file format. And then when I do that, then I simply just run it. Then you click enter. And so watch what is going to happen. So this is internet. And so what is going to happen is when it finishes the alignment, you will see the command prompt will come again. So when it aligns it, this particular file here, corona underscore align.faster, is going to be added into this particular folder called coronavirus. And so everything we are going to do will be found in this particular folder. And that's what I want us to pay attention. For now, the alignment is going on. And then once this blank thing that is blinking is, is over, you will see that the alignment has been done. And then we can go ahead and then have a view of how the alignment looks like. So this is, for instance, if the internet is slow or if the internet is not strong, all right, the alignment is complete now. Now we can have another form of alignment, which we call the matrix. So it's practically the same, but it will take the same input file. But when we come here, we're going to add a flag like this and call it full. Now that one becomes full alignment. And then when we come here, we're going to change the whole of this output. Then the output is going to be in the form of a matrix. So we say matrix of what we see, matrix corona dots out. And then we can do that. This one is going to give us the matrix way of doing that. That's full alignment. So we can be able to use the matrix output to be able to, and then to be able to view it on another platform. So it's also doing that same set of alignment. After that, we are going to do a guide tree, and then that's going to help us to generate our phylogenetic tree. This will be done momentarily. So it takes, if the internet is that much, or if it's strong, this would have been very fast. But the internet is quite slow. That is why we are seeing all these delays. But please pardon me for that. And so before the alignment is complete, we should know that it is also complete now. So the next thing for us to do is to simply do a guide tree. So we have a guide tree that we can build. I want to show you how the guide tree works. So this is the guide tree. And so what I'm going to do is, here we are going to do a guide tree of corona. And so all that I am going to change here is this particular file here, which I call corona.faster. And then I'm also going to change around here, and then I'll just, so you see that the guide tree is being generated. The guide tree is being generated. And so it's at 25% now. It takes a little while for the guide tree to completely be plotted. It's computational, so it's iterating and iterating and iterating. And when it is about 100%, then we would have known that the guide tree is completely. So there's a background work which is being worked right now. And so when it is done, we are done with all the alignment that we needed to do for the multiple sequence alignment. So we are 56% now, and then it's almost done. So we've done three things here. We've done the ordinary alignment where we can view it. We've also done full alignment with a matrix layout, and we've done an alignment where we have built a guide tree. Now it's left, the next thing is we are doing this on a remote computer, which is also called a server, seated far away from here. And after that, we are going to copy the files back to our local computer, and then we begin to work with it locally. This is how we are able to. So it's complete now. It's 100%, 16 out of 16. Okay. So now when we come and then we list, we are going to see that we have this, the original file, but now you can see the alignment is here. We can see the .matrix out file is here, and we can see that the tree has been generated, which is here. Tree coronavirus is generated. Now the next thing is to copy the whole of this folder called coronavirus from the server onto our local computer. But like I said, you don't do copying on this particular terminal. The terminal that is connected to the server, you cannot copy anything from there. You copy from your local computer. So we come back to our local computer here and say that we want to copy coronavirus. So now initially we were copying from my local computer to we were copying from the local computer to the server. Now we are copying from the server back to the local computer. Okay, so I'm just going to highlight this. This will not copy. Don't make that mistake. If I do like this, I'm just copying up to this point, Control V and this, then that copies. Okay, so if I come down here, I'm just going to paste it. So I am copying SCP dash. This time around, remember we are copying a folder. It's no longer a file. The coronavirus contains a lot of files, so it is a folder. And then we created it as a folder, not as a file. Now we just put, so we are copying, we are copying from this, we are copying from a server. So this is the address of the server, and then inside the server we are copying this particular folder called coronavirus, and we are copying it to where? To this place, to my current working directory. I'm copying it to my downloads. So I don't want to alright, so see like this, and so when I come, I just put it around here. So it means when I copy this folder called coronavirus, which is seated on this particular server somewhere, then it will come and be in my downloads. And that way, when I check through my downloads, I am going to find a folder called coronavirus. So now let me do this. It will ask for my password, and then I'm going to do this, and then the password, when you are typing, you see that it has copied everything from there. So now if I go to my local computer right now, I can find a folder seated somewhere called coronavirus. So let me go to my local computer and go to the folder section. You should find a folder called here, and the folder is here. If you open the folder right now, you can see that the FASTA file is here, the alignment is there, the matrix out is there, and then the weak tree is here. Now the next thing to do is to visualize this alignment. So I'm just going to minimize this, then go and look for my UniProt Eugene, which is here. So I'm closing everything from here, and then this is how my UniProt Eugene looks like. you should have downloaded you would have downloaded your Uniport Eugene already. So I'm minimizing almost everything on my PC right now, so that to show you how what is it? So I already have my Uniport Eugene seated here. I've downloaded it and installed it. If you don't have, please download and then. So my Uniport Eugene is here. I go here and look for. This is my alignment. If I want to look at how the alignment was looking like, then I'll just drag this and come and drop it here. It will show me the alignment. This is the alignment of the coronavirus I was talking about. Now, I could actually also look at the matrix out, then come and drop it here. Then it's almost the same thing. And then if I wanted to have a view of the week tree, I'll just come and drop the week tree file there, and then the tree will be built. To be able to build the tree properly, I'm just going to allow this space, and then you come look at this small thing there. You will see that come and click on Gamma Build Tree, this, and then it build a tree for you. So this is how. So you can see the phylogenetic tree of the coronavirus that we've been talking about. Now these are the genetic distances between one species or one strain and the other. These are all strains of coronavirus, the coronavirus we just had recently. And look at how they are connected. We could see the pathway, or we could see the evolutionary tree of how the recent species, this particular two strains, came from. Maybe we should take out this distances and for us to be able to see something. So to do that, simply come and click on this, show distances, and then they are off. And then we can see how they are. So these are the recent parents. Yeah, and then from this particular parent, we can see all the way up to the recent siblings. These two strains of the coronavirus are quite close, but we also noticed something like mouse here. Maybe some of the viruses were isolated from a mouse, and we can see those that were quite close. Now, if we want to look at the clustering, we can also look at the clustering from here. It's a matter of changing this to cladogram. And so this, yeah, so this is the phylogenetic tree actually. We could fit it, and then, so you can now do your own manipulations around here. We'll call it a circular one. No, this is too. It's a little bit. That one is a little bit too. Okay, let me change it to. And then perhaps this default is not too friendly. Let me change it to default and see. Oh no. Okay, I'm trying to see what I can set the tree properly. Okay, so here is the matter of now you doing some kind of see how this is going to fit. So I'm going to come here to this and see how that is going to look like. I think the tree is not too beautiful, but we can actually see some patterns here. We can see that there isn't much of a clustering as we wanted it to look like. Okay. Yeah, great. This is the one that I wanted. Okay, so this looks a little bit beautiful. And then now see how if you take out the distances, we can see the clustering quite clearer. And then see how it looks like. So we can see the virus, all the strains of the coronavirus, how they all look like, and then they are all here. So this is some of the ways through which you can make sense from this. We can see the evolutionary tree. We can see how these are clustered together here. We can also see another cluster from here. And then we can see this. This is a little bit standing alone, and these two are also standing alone. And then we can try to add some genetic distances and make sense from it. If maybe we could try the rectangular, and then perhaps take out the distances, and then we can see it looks a little bit better now. Yeah. And then as we see them like this, could actually reduce the font size, make it look a little bit better, up to 10. Yeah, and that is just okay. Now, if you want, you could export this, or you can copy it to your clipboard and take it to your Microsoft web part or whatsoever. Now, if we leave that part, we can go back to the we can try to check for. So that's the alignment, and then by now we should all know how this works. If you want to build a tree, you come here, click this, you can build your tree. Yeah, the tree is being built, is around here. It's always there. You can copy it, you can change it to a circular manner if you want it. So it's in a circular format now. I can shift this to this side, and then you are able to make sense from it. You can copy it, and then you take it to your Microsoft Word. So that is how it is, how you are able to do alignment, from how you are able to download your FASTA files on your local computer, copy it to a server, do the alignment on the server, copy it back to your local computer, and then come and visualize it, and then you try to make sense from it. And so that is it. If you want the interpretation, I'll do a different video for that. Now let me move straight and do another alignment for you to see. There was another alignment that I spoke about. In which if I pull up my the steps, there was one we needed to go to. We needed to go to this particular site, cluster omega, and so I'm going to go to that one right now. And then type this particular I'm going to type this website. So I wanted to copy it and see if I could type it. So it's actually www.ebi.ac. So it's HTTPS. So I have my 2//. Then I have to be alterating. I'm unable to remember it offhand. So that will give me www.ebi.ac. .uk/tools/MSC. So if I finish with the website, yeah, this comes, it takes me straight to this particular website. So we can see, let's follow what I have given here. I said, so click on services. So let's go to the website and see. where do we have services? So we have services here. We are clicking on services. Okay. So what is the next thing to do? The next guidelines say that we should click explore all our data resources and tools. Let's see if we already have that. All our data resources and tools. So we click on that. And then what is the next step? I said the next step is that click on the checkbox of tools. So let's go and click on the checkbox of tools. And then what is the next thing? Click on Cluster Omega. So let's go to and click on Cluster Omega. So we have our Cluster Omega here. So we just click on that and wait. So here our Cluster Omega is in. What is the next thing to do? Now copy the edited proteins, which the one that we edited, and paste it in the Cluster Omega window. Make sure output view is in Cluster Omega. So I'm going to copy, I'm going back here. This is what they mean. So these are proteins. I'm coming to copy the sequence and paste it here. What are the sequences? When we edited it, they were here. So I'm just going to do highlight A and then come and copy like this. Then I go back to my browser, and this is where I'm supposed to come and paste it. So I'll paste it here. Everything has been pasted. I'll make sure that here it is proteins, and then the output format is in cluster W like it is indicated. Any other thing, I'm not changing anything here. I don't want it to come on my email, so I'll just do submit. This is also another way of doing multiple sequence alignment. And then okay, so the job is already done, the alignment is done, and you can see that the results of your job will appear in this browser window. Job ID is this. Please note the following. You may press shift or refresh or something. So the job has been done. You can see the job ID is here. So click on that, and then you can see, well, it's not yet done. If it is done, maybe it will be notified. On the other side, you can come and click on this, come and copy this job ID and take it to this, and then for instance, if I click on this, it's going to open a new link, but allow the job ID to also be here. So that link is also opening. It's important to say that you can't do this without internet. Especially, we rely on a very robust internet connectivity. If not, a lot of work is being done background. And without internet, it's going to be freezing and freezing. Trying to see this website is running well. So it takes a little while before all these iterations would have taken place. So you just have to give it some more time to see the output. Let me try the job ID again and see if the job has been done. It is still not yet done. But it's important to know that some works are always happening at the background. When it is done, we can click on this job ID and open it, or when this website is open, there will be a short box where you can copy this job ID and put it there, and then it will also print your job. It will print your alignment and everything for you. This is the Windows version, and let me say this part, the alignment is done on condition that the sequences are not many. If you were dealing with a large sequence set, that would be very difficult for you to do. So that's why the command line is always recommended. If you are using the Linux version, you can align any number. It can be in trillions, but here we are limited. It's about 40,000 or something. So the sequences, if they are alright, so the job is done now. So as you can see, now this is your alignment. You can see your alignment quite clear. So that is the alignment. To those who are not so we can look at the result summary here, and then it gives us all. If you want to know the input sequence, you can click here. If you want to look at the output, if you want to look at the cluster, if you want to look at the guide tree, everything is here. If you want to see the phylogenetic tree, it is here. If you want to look at the percentage identity matrix, which is very important in your reporting, come and click on this. Now, and this is going to give you everything. This is your identity percentage matrix. And then you can see the human, all the strains are here. And then I'm not doing interpretation for now. I told you I'm going to do a different video and interpret all this output. This output will be here for 7 days. So any day at all, I can do a video and interpret all this. But this is how you are able to visualize it and then have a clear understanding of how your alignment looks like. So we get back here. That's your result summary. So what about your phylogenetic tree or your guide tree? Let me click on the guide tree and see what happens. So this is the guide tree which is here. So we can see it's quite clear now. It's quite clear now. And so we could, if you click on real, so you see it's a little bit different, and the cladogram will give you this. If you want a phylogenetic tree, you come and click on this, and then your phylogenetic tree would also be built. So this is how the phylogenetic tree looks like in terms of coronavirus. We can see the relationship. These are the recent siblings, and these are the grandparents. Obviously, this particular strain and this strain here did not have anything in common. They just came from, what is it? But it's from this particular strain, this one we have here, which resulted into this, and then this. And then from here, we have this, and then over there. Obviously, the strains that are the most closest is this one on top here, and then this one that we have here. They are the most closest. Here is closer to this, but not too close. If we add genetic distances to it, you can see it. And the genetic distances are already at the last part of it. As you can see, negative 0.09. We can take 0.02 and then 0.01. You can see that they are quite closer than 0.02 and 0.09. And so that's how it is. We use this particular genetic distance to know how different or similar they are. And here we can say these two species, around this one and that one, they seem to be standing alone because they actually did not have any siblings. Here we actually saw some siblings over there. I'm not doing interpretation for today. So this is how we are able to do our alignment, multiple sequence alignment, both on command line and then also on a server, and then how to also use the window interface to be able to do that. If you are watching the video, if you like this particular video, why don't you give me a thumbs up and subscribe, and then allow other people to also benefit. I've already done some video on the global alignment and local alignment. You can check that out. watch out for another video where I am going to interpret all this and then let you know how to make sense from it. But this is the coronavirus all of us were talking about. I just picked a few of them and I decided to have a look at them and how they are connected. If you want to download the tree, you can just click download phylogenetic tree to download it for you. You can explore the other small tabs which are here, and then you're going to have these results will be kept here for the next 7 days. After that, the owners of the website will dispose it off. Now, this was the website I was talking about. If you had copied the job ID like I spoke earlier, you would have come here to put the job ID here and then retrieve it, and retrieve the same thing that we are watching right now. So that's another way of also looking at it. But if you are patient enough, the whole results will be out like we have it right now, and then you can just have a look at it. On the other side, there are some of us who may want to build a tree on our own. So come here. This is the syntax. This is how the one who wrote the program, the computer background program, this is how it is. Let me show you another way of visualizing this particular. So you can come here and just copy it up to this last part. Here, right click and copy it. Now go to a new tab and type this Center for Genomic Epidemiology. It's already there. Now come and click on that. And then go and click on services. That opens. Then check something. You see tree viewer or my tree viewer. I'm looking for that. Yeah, tree viewer is here. You're going to see a small dialog box that will be asking you to upload anything. So if you click on that, just wait a little more. These delays is because of the internet. If not, everything will be fine. So when that is opened, all right, so we are going to load. Come here and paste that thing that you copied. That's paste it here. Now click on load tree. It will simply load the tree for you. As you can see, the tree is on top here. Now you can actually now also do your manipulations by changing the figures here, the colors and whatsoever, to be able to get the tree to the way you want. When you finish, you can download the tree as a PNG or you can download it as a PDF file, and then your tree is also here. The same thing as you can see those that are clustering together, those that are sparsely clustered, you will also see them there. So this has been your video of today, and watch out for interpretation of how to be able to do multiple sequence alignment, and how to be able to interpret them and make sense from it. Thank you. My name, as usual, is Bigba, and then this is the video. If you like it, please, why don't you share, and then subscribe to my YouTube channel for more on some little bit of bioinformatics and a bit of data science. And then anytime I upload a video, you'll be the first to see. Thank you, and see you. If you have any query, please put it in the comment box, and then I will come there and then have a look at it. Thank you.